Hello everyone, welcome to another video of Digital Logic. Today in this video we are going to study about how to prepare basic gates with the help of NOR gate. In the previous video we have discussed about how to prepare basic gates with the help of NAND gate. We know that NAND gate and NOR gate are the universal gate and any kind of the Boolean functions can be performed with the help of universal gate. So in the previous video we discussed about how to perform Boolean inversion, Boolean addition and Boolean multiplication by using NAND gate only. Now in this video we will discuss about how to do the same thing with the help of NOR gate only. So let's start our video. First of all, how to prepare NOT gate from NOR gate. To do this we have two methods, but before discussing about the method of preparing NOT gate from the NOR gate, let's see the truth table of our NOT gate. This is our truth table for the NOR gate. We know that the output of NOR gate will be high if the input is low, and the output of NOR gate will be low if the input is high. So we will produce exactly the same output as produced by the NOT gate with the help of NOR gate only. To do this we have two methods. Our first method is this one. Here you can see both the input of our NOR gate is merged into a single input. So the input of NOR gate is named as A and A. And we know that the output of NOR gate is the complement of its Boolean additions of the input. And here we have two inputs, that is A and A, which is merged into a single one, and the output of our NOR gate will be equal to A plus A complement. This output is equivalent to the output of our NOT gate. Let's verify this by using the value of our input. If the value of my input is 0, then both the input of my NOR gate will be 0 because it is merged into a single input here. So A plus A, that means 0 plus 0 will be 0 and its complement will be 1. Likewise, if the value of input is 1, then both the input of my NOR gate will be 1 and 1 plus 1 will be 1 and its complement will be 0. So output of my NOR gate is equivalent to the output of my NOT gate. You can compare the value to the truth table of my NOT gate. So if the input of NOT gate is merged into the single input, then it will act as NOT gate. We have verified by using the value of our input. To prepare NOT gate from the NOR gate, we have another method also. This is my second method here. In the second method, any one of the input of my NOR gate has to be always low. Here I have kept B as low, but you can also keep A as low and change the value of B. But I am going to change the value of A here and keep B as low. So the output of my NOR gate will be Y is equal to A plus B complement. And this output is equivalent to output of my NOT gate. Let's verify this by using the value of A. If the value of A is 0, B is 0 here because I am not going to change the value of B. So A plus B will be 0 plus 0, which is equal to 0, and its complement will be 1. Likewise, if the value of A is 1 and B is 0, since we are not changing the value of B, so 1 plus 0 will be 1 and its complement will be 0. You can see this output is exactly same as the output of my NOT gate. That means we have two methods to prepare NOT gate from the NOR gate. In our first method, we have seen that if both the input of NOR gate is merged into a single input, then also it will act as NOT gate. Likewise, if any one of the input of my NOR gate is kept low, then also it will act as NOT gate. Now we will move toward our logic gate simulator, where we will compare the output of this first method and second method to the original NOT gate. This is my logic gate simulator. This is my original NOT gate, where A is my input and Y is my output. Likewise, this is for my first method. This NOR gate, the input of this NOR gate is merged into a single input here, and Y is my output. And this is my second method, in which I am going to keep the value of B always low, that means 0. And this A and B are the input for this NOR gate here, and this Y represents my output. Now let's verify for both the value of A, that is 0 and 1, whether the output of first method and second method is exactly same as that of our original NOT gate or not. In our original NOT gate, the value of A is 0 here, but the output is 1. Likewise, in my first method also you can see the input A is 0 and the output is 1. And also in my second method, the value of A is 0 and also the output is 1. We are not changing the value of B here, so let's the value of B is equal to 0 as it is. You only check output by changing the value of A here. So now I'm going to change the value of A as 1 in all three cases, and we will compute the output in all three cases. Here in original NOT gate, if the value of A is 1, the output is 0. Likewise, if the value of A is 1 in the first method, then also the output is 0 in the first method. And similarly, in the second method, when the value of A is 1, you can see the output is 0. That means this first method and second method is exactly producing the same output as produced by our original NOT gate. Hence, they are representing NOT gate. Our second topic of the video is how to prepare OR gate from the NOR gate. But before preparing OR gate from the NOR gate, let's check the truth table of our OR gate. This is our truth table for the OR gate. We know this truth table from the video of our OR gate. To prepare OR gate from the NOR gate, we will combine two NOR gates. This will be my first NOR gate. Here A and B represents the input of my first NOR gate, and Y is equal to A plus B complement represents the output of my first NOR gate. Now I will connect the output of first NOR gate to input of second NOR gate. From figure you can see both the input of second NOR gate is connected to output of first NOR gate. That means the input of second NOR gate is merged into a single input. And we know that when both the input of NOR gate is merged into single input, then the NOR gate will become NOT gate. So this second NOR gate is here representing the NOT gate. Input for my second NOR gate is the output of the first NOR gate, that is Y is equal to A plus B complement. And also this second NOR gate is representing NOT gate here. So the output of the second NOR gate will be equal to complement of the input. So output is Y is equal to A plus B double complement. This Y is equal to A plus B double complement represents overall output for the combinations of these two NOR gate, and this output is equivalent to output of our OR gate. Let's check whether or not this final output of the first and second NOR gate is representing our output for the OR gate. Since we have two inputs, so the number of possible combinations will be 4, that is 0, 0, 0, 1, 1, 0 and 1, 1. If the value of A is 0 and B is also 0, then the final output will be A plus B double complement will be 0. You can see here A plus B will be 0 plus 0, that is 0, and its complement will be 1, and again its complement will be 0. Similar to the other three cases, when the value of A is 0 and B is 1, you can see the final output is 1. Here also, if the value of A is 1 and B is 0, the final output is 1. Likewise, 1 plus 1 will be 1 and its complement will be 0, and again its complement will be 1. This final output of our combinations of first and second NOR gate is exactly same as the output of our OR gate. You can compare to the truth table of our OR gate. Now this is my logic gate simulator. This is my original OR gate, and this is the combinations of two NOR gate which we have discussed. I'm going to compare the output of both the cases here, whether the combinations of two NOR gate in this way will give the output of my original OR gate or not. So here you can see the value of A and B in both the cases are 0 here, and the output is also 0. Suppose if the value of A is 1, then you can see the output in both is 1. Likewise, if the value of A is 0 in both and B is 1, then also the output is 1. And last one is if both A and B are 0, then also the output is 1. That means the combinations of two NOR gate in this way is representing our OR gate because they are producing the same output. This is our last topic for this video. We have discussed how to prepare NOT gate from the NOR gate, and also we have discussed how to prepare OR gate from the NOR gate, and now we are going to prepare AND gate from the NOR gate. To prepare AND gate from the NOR gate, we will combine three NOR gate. But before preparing AND gate, let's check the truth table of our AND gate. So how to prepare AND gate from the NOR gate? To prepare AND gate from the NOR gate, my first NOR gate will be this one. Here you can see both the input of my NOR gate is combined into a single input, and we know that when the inputs are merged into single, then the NOR gate will act as NOT gate. So the output of this first NOR gate will be a complement, because this first NOR gate is acting as NOT gate, and NOT gate is the inverter and it will complement its input. So the output will be a complement. Likewise, this is my second NOR gate. Similar to the first NOR gate, in this second NOR gate also we have merged the input to a single input B here, and the output will be B complement. The output of first and second NOR gate will be the input for my third NOR gate. So this is my third NOR gate here, and we know that the output of NOR gate is the complement of its Boolean additions of its input, and its input are A complement and B complement. So the output of our third NOR gate will be Y is equal to A complement plus B complement to the whole complement. This Y represents the overall output for the combinations of these three NOR gate, and this output will be equivalent to output of our AND gate. Let's verify this by using the value of A and B. Since we have two inputs A and B, so possible combinations for our input will be 0, 0, 0, 1, 1, 0, and 1, 1. If both the value of A and B are 0, then A complement will be 1 and B complement will be 1, and A complement plus B complement will be 1 plus 1, and in Boolean algebra we know that 1 plus 1 will be 1, so its complement is 0. Similarly, if the value of A is 0 and B is 1, you can see the overall output is 0, and for the rest two cases the output will be 0 and 1. This overall output is equivalent to output of our original AND gate. You can compare the value to table of AND gate. Come to this logic gate simulator, where we will compare the output of combinations of three NOR gate to the output of original AND gate. I have my original AND gate here. Here I have written original AND gate, and this A and B are my inputs, and this Y is my output for this AND gate. Likewise, this is the combinations of three NOR gate here. This is my first NOR gate, this is my second NOR gate, and this one is my third NOR gate, and A and B represents the input. Here you can see the input of first NOR gate is merged into a single input A. Likewise, for this second NOR gate, you can see the input is merged into single input B, and the output of first and second NOR gate is connected to the input of third NOR gate here, and this Y represents the overall output for my combinations of these three NOR gate. Now we will change the value of A and B here, and we will compare the output in both the cases. For our first case, A and B are 0 here, and the output is 0. Here also A and B are 0 and the output is 0. And when the value of A is 1 in both cases, you can see the output is still 0 in both the cases. Likewise, if the value of A is 0 and B is 1, then also the output is 0 here. But when both A and B are 1, then the output in both is 1. That means the combinations of three NOR gate in this way represents our AND gate.